Welcome to the Design Vault, a show about the past, present, and future of design. The Design Vault is a conversation hosted by Albert Shum and Tamer Abanami, reflecting on iconic products and ideas from the past and rethinking them from new perspectives.
Hey, Albert, how you doing?
Hi, Tamer. How are you?
I'm good. Today we're talking about the Microsoft Mouse 2.0.
2.0. I think today's episode for me, it's one of those episodes where there's obviously a certain amount of nostalgia, but also it's a theme that I think a lot of companies are actually struggling today. I think how do big software company decides to do its own hardware, what kind of environment to create those products in terms of the designers, the processes, the tools. And I'm really excited to kind of go through some of the basics. The Microsoft mouse was introduced in 1993, which is quite a long time ago if you think about it. But actually, that wasn't the first mouse created by Microsoft. The Microsoft Mouse 1.0 was actually done, I think, back in 85. So what made this mouse different to 2.0 is the first in-house design mouse created by Microsoft.
Right, and previously I think Microsoft had outsourced its work, and here they actually have hired industrial designers and people like mechanical engineers, etc.
Yeah, building their own product and getting it to manufacturing, to creating the distribution and the channels to get it to customers. So it's quite a big effort to do it.
Why would Microsoft choose to do this? They were a software company, and why did they think it was important to invest in this product and do it?
Yeah, that's why this product is so relevant to today. When do you decide to actually not just only do the software, but actually do the hardware and the services? And oftentimes when there's these technology shifts, when you're trying to create almost like a new paradigm, and new user interaction, new behaviors that you have to help educate and even in some ways train your customers to use. You have to get over that hurdle. And that's why I think for companies like Microsoft, tech companies, the investment in hardware is really important. And if you think about it back then, the idea of the internet was really just emerging, the browser, and how do you use your keyboard and mice together to navigate information, to be productive. I think that's why Microsoft decided it was the right time to invest and build their own products.
Got it. And really, there's so much detail that went into the development of this product. And we're fortunate to have Steve Kaneko, who was the designer of this mouse. And for those who know Steve, he's a designer's designer.
And designers.
Yeah, kind of. He's really deep. He's one of the deepest designers I've worked with.
Triple threat.
Yeah, he's a triple threat. And you know one of the things I always remember about Steve is we had talked about his work on the mouse many years ago, and his face lit up and he went into this surgeon level detail of the anatomy of the human wrist. And I remember just how that blew me away. And as I worked with him more, I realized he brought that level of depth to everything he worked on. So I'll kind of cut our chit chat short because I really think this is going to be a fascinating conversation for you to hear what Steve had to say about how the Microsoft Mouse 2.0 came to be. Let's cut to interview. So I woke up really excited today because of our episode being on the Microsoft Mouse 2.0, and we actually have a special guest here today. But I have to admit that I'm way too excited to introduce our guest. So, Albert, I think it's better if you do it. I'm such a fanboy of this gentleman, so please go ahead.
Thank you. Well, I feel very honored to have the chance to introduce a good friend, a colleague, a mentor, a collaborator, and really the inspiration for a lot of design work that I've been part of. And more importantly, I think our guest is someone who's a true maker, someone who takes design as almost an ethos, a way of being. And so I'm very fortunate, very honored to have our special guest from our very own Pacific Northwest, Steve Kaneko.
Hey, thanks, guys. It's good to see you.
It's good to see you. It's been a while.
It's been, what, Dahmer, it's been maybe a few years. Albert, maybe 6 months or so.
Yeah.
But no, we go back, I think we just said, maybe about 10 plus years. Easily, right?
Easily.
So it's good to see you guys.
So I'm really interested to hear some of your perspective. The Microsoft Mouse 2.0 has a huge story behind it and a lot of things that people may have not learned. So maybe you can set the context for us, Steve, with kind of how you came to join the crew at Microsoft in those early days and how the hardware production was happening at that time in design, and then what led to this mouse.
So much fun. So let's start. If I were to go back, when I joined Microsoft in 1991, to be perfectly honest, I knew very little about Microsoft, the company. I didn't even know what product or project I was going to work on because it was secret. And it was hired by Stuart Ashman, who was a fellow industrial designer who worked at Fluke Corporation. We kind of crossed paths. It became clear from day one that the project was still a secret. Even Steve Ballmer didn't really know it was being done. So hiring one industrial designer was probably noise in the whole equation. But we were a small hardware group at the time. It was like, I think, less than 40 people.
Wow.
And I was hired as the first full-time industrial designer. There were probably 5 people in the company who called themselves designers at the time. The others were graphic design. Virginia Howlett was there. We started interaction, the interface. And it was, there are these little pockets. Debbie Fromholzer was at HP. She was my mentor at Lake Stevens, Hewlett-Packard when I interned there. So coincidence. But it was a ragtag of designers kind of embedded in engineering orgs. But it became clear that industrial design and my role in particular was to actually do what was necessary to actually first and foremost cost reduce the mouse. It was not a project. Steve Ballmer and Bill Gates would have been completely happy with what was then the Dove Bar mouse design.
So there was a mouse.
There was a mouse that existed. There are a couple of mice that had Microsoft brands on them previous to the project that I was assigned to. The first one was done like 1984 or something. Believe it or not, it was designed by a fellow named David Strong, who was a graphic designer in the Seattle area. How he got that job, I have no idea. But it was called the two green-eyed mouse. Then I think Microsoft got serious about design, and this is an important thing to capture, is back in the, I'd say, mid-'80s or so, they hired Mike Nuttall, who was with Matrix Product Development, and Bill Verplanck, who was with ID2.
And this is before IDEO.
Before IDEO. Yeah. And they both, I'm sure there's more people involved. Jim Yuchenko probably was in that involved. They designed the mechanical encoder and mouse called the Dove Bar. And it was a beautiful, modern design. I think the thing to take away from that, will roll into what we did with the Mouse 2.0, was Bill Verplanck in particular. Not only was the product beautiful, but Bill Verplanck was pioneering human-computer interaction at the time. And this is where they started to actually quantify the performance of a design based on a law called Fitt's Law, which is about task performance relative to, as I learned, grip architecture, anchoring, and all kinds of concepts.
Yeah, but also like tracking
in particular. Yeah. So it became clear from day one, which I didn't quite understand until I actually understood Microsoft, that the reason why hardware had to exist and why it was important and why they were in the business, not only secretly was it a really profitable business, which most people don't even understand, right, or know, but in order to actually make progress and pioneer innovation in the software space, you have to be involved in the human interaction and things like the mouse. So fast forward a little bit. From day one, the project was secret, but it was first and foremost a project to cost reduce the mouse. So I brought back my industrial design training in design for manufacture and assembly, which is this geeky term for how do you actually build and compose a product from an engineering standpoint so it's friendly for robotics. Robotics was relatively new at that time.
For the manufacturing.
For the manufacturing. So it had Z-axis assembly, tangling in bins, all
the
those
whole
things.
Assembly.
So we blew apart every component of the product and actually quantified variations between 10 different configurations in order to reduce the statistical cost of a product based on how design manufacturing engineers call quality.
Right.
So start from there. We had to cost reduce the product. We're moving also from a mechanical encoder, which had a lot of flex circuits and complexity to it, to an optomechanical encoder, which kind of reduced some of the cost but increased reliability. So that was the reason why we had to redesign the mouse to begin with.
For our listeners who are not savvy about encoders, can you explain its role in the mouse?
Basically, think about the encoder as the thing that captures the movement of the ball that's inside of a mouse. That's it. And in today's world, there's no ball, right? Back in these days, you have this rubber ball, literally, that's rolling on the table. And the encoder is just the chassis around it that's capturing its movement in X, Y dimensions.
So the technology that enabled this mouse, one of the beginnings of an inflection point is this optical component.
Optical component. It was still going through a transition at the time, but very quickly Microsoft and everybody else moved it to a fully optical system. Right. But optomechanical was the thing and the reason why.
And improved performance. It was less cost, less parts.
Reliability. When you think about, resistance, friction and all these other components. So first and foremost, my job was actually manufacturing engineering for the first 6 months. Yeah. No one knew that I was actually an industrial designer, even when we started working with our
actually, that's a key point. A large part of industrial design, it's not just the form. It's obviously how do you build it? How do you make it?
Correct.
I think going deep into understanding of manufacturing is so core to, I think, the industrial design process.
Correct. In this case, it's like the architect understanding and building the system of the HVAC, the cooling, how are you going to passively, heat the house or cool the house, et cetera, right? So that's the fundamentals of engineering and manufacturing. Because in the end, we're talking volumes of multiple millions per month, not a year.
Right.
The scale of manufacturing is massive.
Right.
So if you take 1 cent or 2 cents out of a product, you're making a pretty significant dent in the business bottom line, right? So imagine taking $1 or whatever it's going to be. Things start to add up pretty quickly and pay your salary, certainly. We needed a reason why the industrial design or the form exists. A new one would exist. There had to be a reason for its existence. And at the time, because more people were using computers and more familiar with mice, issues around strain, fatigue was coming up. That was a new concept in the world. Said differently, repetitive strain injury and other things was a popular part of press. Whether it was real science or not didn't matter. So it became clear that building on task performance that we kind of carried over from baseline research that Bill Verplank and others did, combined with biomechanics and kinesiology, which is now a more formal part of ergonomics.
Right. Actually, the field of ergonomics.
The field is where we started to add now the story, which is why I quickly had to hire some experts around me because I didn't know enough. So we hired Edie Adams from the Joyce Institute, who was in Seattle, and she happened to be a product design ergonomist. And she partnered with me for a good 3-4 years and helped to establish ergonomic principles around the design of the mouse that had to do with what is biomechanic neutral, what is the anthropometry scale of pinch grips and hand sizes and whatnot, what are the concepts we should keep in mind outside of task performance regarding static load on the forearm, wrist deviation, ulnar, radial, supination, pronation, all these terms that I had to learn as a designer. So she set up those basic principles. So some of that criteria was set up with Edie that we had to now design a shape around. We went further and hired Dr. Bryce Rudder from Metaphase Design Group out of St. Louis.
Oh, yeah, Metaphase.
And Bryce is connected to University of Illinois and Carl Newell, who is the chair of the kinesiology lab there. We actually took ergonomic principles up to 200 different variations of models, easily past that, and actually put goniometers to actually measure wrist flexion and whatnot, force transducers to measure pinch grip and anchoring pressure and whatnot, and created a means in which to track using Fitt's law performance. So we found and designed to find an optimal solution between what was happening in software, given the variables of software and cursor and icon size and cursor acceleration, et cetera, biomechanic load, which has to do with fatigue and grip architecture, convenience, and ease, and basically the psychology, and force, which had to do with quantifying how hard you were pinching versus not.
How much effort it takes.
The goal is not to eliminate all load,
Right.
but it's to optimize it relative to what you do in software versus hardware and how much the human takes on.
Yeah, and can you walk through the process? Did you create prototypes?
Yeah.
How did you
So
come up with different forms or different, I would say,
Yep.
design directions?
Yeah, you start with basic composition, like the minimum size, optimal size for
the package, right?
pinch, grip, girth. Actually, you're starting with the encoder and what's minimum size.
Right.
Truth is, everything is smaller than what we needed. So everything got bigger based on ergonomics, which is now it became a pure industrial design activity to find the optimum size. So you work on anthropometry, which is the body scale, first and foremost, which has to do with hand sizes from women to men, North American, international, etc.
Right.
And you do your best to actually now create variables amongst that. And then you have things like the height, which is key, which is how easily that would affect how easily and readily available a surface is for you to rest on when you're not moving the mouse.
Oh,
right?
So your palm and
Right,
the
and that's
whole resting position.
reducing what's called static load on your forearm. So you got something to rest on. It's like an ergonomic keyboard when you have the palmers.
Sure.
You don't use the palmers while you're typing, but it helps with your back and shoulders. So the mouse has the same need. People just didn't know it. Everything was designed for looks or manufacturing.
Right.
And in one case with the mouse Dove bar, performance was key, but there wasn't a physical assessment put on top of that. Tom, you had a question?
Yeah, no, this is great. We've all worked together before, and what I've learned from you early is there's this power of iteration.
Right.
And iteration can happen for multiple reasons. And I found it most interesting when you're confronted with a challenge or something unexpected. And we're talking about how the ergonomics and the human side really are an important side of this. And I know you've iterated a lot on that. Were there other challenges that faced this project that you had to iterate your way out of or pivot out of because you hit something that was unexpected?
Yeah, the one that comes to mind is a part of ergonomics, as the way the professionals talk about it, is also psychology. So this notion of product semiotics or signals that you create.
It's a perception?
The perception of form and what it's for. This is like way back when, in I forget, 70s or so, there was this notion of product semantics, which is the meaning of form and the metaphor and all these other things.
Yeah.
Without going too far into it, every product or shape communicates whether or not it is designed for you or not. And as a designer, you have to actually prototype things to actually signal the right comfort cues and other things like it, which is why I'm holding up a mouse right now, which is like serial number 1, which is kind of fun to share with you guys. That's why it's asymmetrical, right? We designed this mouse, believe it or not, for ambidextrous use, but it's biased towards a handedness, which is 90% of the world for the most part, right? And even 50% of the lefties use the mouse in their right hand. So without being overly biased about it, what this little detent did was create a thumb cue to say, this is how you use it, where you place your thumb for the pinch grip that's appropriate. And it signals with the organic shape that it was designed to interface with the human hand.
Right.
Previously, the bar, as beautiful as it was purely an exercise in pure form.
It was very symmetrical.
It was symmetrical and clean.
Yeah.
It was like modern art.
Yeah.
This had to send a different cue that I'm designed for comfort. And that is so every detail. So there's the geometry and then there's the psychology of form that were both parts of this.
And just for our listeners, when you're saying Dove Bar, you're talking about the original design model.
It was the original model, the product designed in 1986 by ID2 and Matrix Product Development. And it was a white product with the Microsoft logo on it. Yeah. And it was the product that was in market at the time with Microsoft's name on it.
Yeah, and I feel like you really established almost like a new visual design language. Would that be going too far, or
but
no?
Nothing was this organic at that time, which made it hard because you guys appreciate this. CAD and surface modeling and be able to capture this stuff was not
just
readily available.
Yeah, it's like AutoCAD.
So I've got one more prop for you. Okay, and I think you guys appreciate this.
Yeah, I'll describe what Steve is pulling out. He's got a Ziploc bag with a clay model.
Oh, it's wrench-shaped model.
Final scan, 5/16/92. Okay?
Yeah.
And what this is the final industrial design model after over 200 iterations, all this ergonomic testing, all this psychological evaluation of form, communicating the right form factor, cues, and everything else. It all came down to a rasp, wren shape, a bandsaw in a rented shop, because Microsoft had no shop. That's where I was working effectively. And I think I was moving from my apartment to a place home, and I probably had the bandsaw in my basement and whatnot. But the final product, after all that research and work, had to be hand carved. It had to be Bondo to be perfectly lit. And I'm using calipers, believe it or not, to make it precise. The reason it's crusty on the side was we had to, at the end, create the perfect form that was final master. So it's called the master. And this has been tooled and scanned ultimately on the top surface.
So that's the actual...
Yes, the actual one that was the final. And I had to extend the sides about a 1/4 inch out, because what we did was start with a plan view.
Yeah.
And the plan view, believe it or not, you guys are design geeks. Fibonacci series, Golden Mean.
Yeah,
it's on that. It's from a plan view.
The
this is a ratio, 1 by 1.618. Okay.
Yeah.
Then we created that shape and projected up with the right draft angle, and it intersected this surface. So I had to extend the surface beyond what was necessary to accommodate the fillet or the round.
Right.
And then we found the intersection. And on the product, then we started with a tight radius, and it starts to get softer and softer towards the bottom, which creates motion to the product, but it also sent a stronger cue that your hand and the interface towards you was compassionate and, gonna inviting to the end user. But this is the final scan.
That was before CAD, so everything was
this was hand built. No, CAD was clumsy.
Right.
So there was no way to get the super organic
surface,
nuance.
Right, that surface
contour. And so this was scanned and then reverse engineered into tooling path. So CAD was kind of rough at that time.
Sure.
Frankly, I was not good enough in CAD 2 to actually communicate and get the nuance.
And the limitations then would actually drive the design versus, I think, this create more of a purity of form that allows you to express your intent.
After all that work, we were not going to compromise on sculpture. So, we start with engineering and manufacturing and cost reduction and manufacturing engineering. We move to ergonomics and human-computer interaction principles. Lastly, and not least, is now amongst all that, you actually put a layer of artistry and art and human emotion and imperfection on top of all that, without compromising anything that came before. If asked, those are probably the 3 different layers, to me, of a good product design that any industrial designer or team has to consider. But it's almost in that order, depending on what kind of product you're working on, right? But so that's how you end up with something like this, that, as simple as it is, most humans don't have any idea what goes into something like that. Won't get into the co-injection molding and other things like it. But.
Hey there, thank you for listening. We hope you're enjoying the interview with Steve Kaneko. Tune into part 2 where the conversation continues. Don't miss out.
Thank you for listening. The Design Vault is brought to you by hosts Albert Shum and Thamer Abanami, and is produced and edited by Romina Hakim, Tonio Telles, and Poonam Patel, with music by Red Lips Media, brand design by Rafael Poloni. Join the conversation on social media at the Design Vault Podcast on Instagram. The views and opinions expressed in this program are those of the speakers and do not necessarily reflect the views or positions of any organizations they represent.